All right, I think it is about time for us to get started. So, good morning, everybody. My name is Lily, and I'm an interpreter here at Natural Bridges State Beach, which is a California state park. Today, we're going to be talking about the tide pools, but again, just to reiterate, I want everybody to grab two things: a pencil or something else to write with, and a piece of paper. We will be doing some drawing towards the end of today's program. So either make sure you're leaving yourself enough space or using the back of a piece of paper, or grab a whole other piece of paper for yourself so that you don't have to find a new one. And again, welcome. I'm Lily here at Natural Bridges State Beach. So let's start out today's program. Now, I'm here at Natural Bridges State Beach, which is a California state park here in California, in Monterey Bay, on the northern edge of Monterey Bay in Santa Cruz. Santa Cruz is just a little bit south of San Francisco if you're not local. This is a video of the bridge, the natural bridge that the park is named for. It's a little hard to see from this angle, but there actually is a hole that goes right through the middle of that big old rock there. And you can see on top of it, there's all kinds of seabirds, pelicans and seagulls and cormorants. They all love hanging out on top of that rock. Now, let's zoom out a little bit more so that you get a better view of what the bridge actually looks like. And there you can see there's a big hole right in the middle of that rock, and that is a naturally formed bridge that the park is named for. But there actually used to be more. There used to be 3 natural bridges in the park. I'll make myself a little bigger and I can point them out. So there used to be another one that went right here. That one fell down in the 80s. And there used to be a third one that was over this direction out into the ocean. And we actually had something really special happen earlier this year that has kind of changed our name again. We found a new bridge. We had some really big storms in January, and those storms are so strong that they actually broke through the rock. In January, this hole was only about this big. It was about the size of a dinner plate. And now it's so much bigger that a person can actually crawl through it. So again, we can be called natural bridges, plural, because we have a new bridge starting to form, and it's getting bigger and bigger every day. But we're not here to talk about geology. We're here to talk about the tide pools. Do you know what a tide pool is? Have you ever been to the tide pools before? If you know what a tide pool is, or you think you know, why don't you either write it down on your piece of paper or very quickly tell somebody next to you what you think a tide pool is? There were probably some pretty great answers. A tide pool is just a hole in the rock that's been worn away by the ocean, and it's made a little pool. There's water in it, and all kinds of things live in those tide pools. But how exactly do they form? This is a time lapse of the Natural Bridges State Beach tide pools. You can see right now, this is mostly water. There's not really much out there, and the pools are actually the rocks underneath that water. This is at a time of day called we call high tide. High tide is when the ocean water has risen up and is covering a lot of the rocks. Now, we're going to watch a video and take a look at this tide pool area here. And this is a time lapse throughout the entire day. Do you think the water is going to stay the same level, or it's going to change throughout the day? You can go ahead and write it down or tell someone, and we'll watch for a little bit and we'll see what the water is going to do. You might already be able to tell, but that water is going out. The water is getting lower. You're seeing more and more of the rock exposed as the day goes on. And you're seeing a lot more people out there too. There was nobody out there during the earlier time of day when the water was covering all of the tide pools. But now that the water has gone out, our tide pools are exposed. You can walk around and you can see, you can look inside of the pools and see all kinds of animals that live in them. The water's gotten a lot more calm, so it's safer. It's farther out, so you're not going to get splashed or slip. And this is the condition that we want our tide pools to be in when we go visit them. And here again, you can see just how high that water was earlier in the day. It was totally covering the entire tide pool area. And later on in the day, it became exposed. And as the ocean does this every single day with its high tides and its low tides, that water slowly wears away the rock, forming these pools. So this is a photo of the Natural Bridges State Beach Tidepool shelf. And I've drawn some lines on it. I've drawn some lines across the different zones or habitats of the tide pools. Do you know what a habitat is? If you think you know what a habitat is, why don't you either write it down or tell somebody quickly next to you? What do you think a habitat is? You probably had some great answers. A habitat is just a place, any place, where there are things that are alive. It's a really, really simple definition, but it's this very broad word. A habitat can be a desert. A habitat can be a redwood forest. A habitat could be our tide pools. And they're all very different. They're different environments with different factors that bring different kinds of life. Is a desert going to have the same kind of creatures and plants in it that a redwood forest would? Probably not. And our tide pools are the same way. Because they live so close to the ocean and they rely on the water coming up and down every day, you get these miniature habitats along the tide pool shelf that we call zones, the different zones of the tide pools. And here I've labeled them for you. As you're farther away from the ocean, your life is going to be very different than if you live really close to the ocean. You'll spend less time out of water if you're farther away. You'll spend more time underwater if you're closer to the ocean. So we've labeled them here. We have the splash zone, which is the farthest away from the ocean, the high tide zone, which is getting a little closer, the mid tide zone, which is getting even closer, the low tide zone, which is hardly ever out of water, and the subtidal zone, which is always underwater. So today we're going to take a little bit of a virtual walk through the tide pools and look at some of the animals in our different zones. We're going to start farthest away from the ocean first in the splash zone. Take a look at this photo that's behind me. Do you see a lot of things in the pools there? Do you think there's going to be a lot of plants or animals living in the splash zone? What kinds of challenges do you think they might have? Well, we're going to talk about some of that together. You can see in this photo, there's really not a lot going on in the splash zone. It's a super hard place to live. The splash zone is the farthest away from the ocean, so it dries out really quickly. And its biggest challenge, in fact, is water loss. The sun beating down on those small, shallow pools every day means that they either dry out or they condense a lot. The water evaporates away. So the animals that are here have to change their bodies to best fit their environment. That's quite harsh. Do you know the word for when animals change their bodies to fit their environments? You can write it down if you think you know, or tell somebody. You might have said it. It's adaptation. An adaptation is just a way that an animal changes its body to best suit its environment. So we'll talk about some of the animals that live in the splash zone and their adaptations. These are a couple of them. We have some barnacles up above me, some periwinkle snails here. We have limpets up in the corner up this way, and copepods, which are down and across from the snails. And we'll talk about each of them in detail. Let's start out with the snail. This is called a periwinkle snail, and they're super, super small. It's hard to tell from this photo, but if I took my pinky finger and I divided my pinky nail into quarters, a periwinkle snail would be about the size of a quarter of my pinky nail. So they're really teeny, teeny, tiny. But they have a special adaptation that helps them keep water inside their shell. It's called an operculum. Why don't you go ahead and say that with me? Operculum. Very good. An operculum is like a front door that they can close to make sure that no water leaves their shell. And you can see on this snail here, you can see its squishy foot that's closing to the operculum here. And then on the one over here, you can see it's covered by that brown circular looking disc, and that's the operculum. If it starts to dry out, it can just close its front door and keep all that water in. This is called a rough limpet. Now, it's called a rough limpet because you can see on the outside of its shell, it's got all these rough spots. It's not smooth at all. And limpets are sort of similar to a snail. They have a big squishy part of their body called a foot. And it's not a foot like we have, it's a foot like a suction cup that helps them suction down to the rocks. And they suction down to the rocks really, really tight, so tight that water can't escape from their shell. In fact, our limpets actually have a home. They have the same spot that they suction down to every day. And they suction down so hard and so often that it's actually made a small hole in the rock or a scar. And this little spot that's their home is called a home scar. They return to the same spot every day and it perfectly fits their body and it helps them suction down to the rock really well to avoid drying out. These are barnacles. There's a couple of different animals in here, so I'll point them out. The barnacles are the ones with the white outside, and they've got this kind of almond shape opening. Now, there's something interesting that I'm noticing about some of these. What are you noticing about our barnacles right now? You can tell someone to write it down. What do you notice about the barnacles? You probably noticed a lot of things. One thing that I'm noticing is some of them, like this one right here, they have these two little shells almost that close like this. And some of them, like this here, it's a hole in the middle. What do you think is the difference between the two of them? Are they the same or are they different? What's different? Do you have any ideas? Well, I'll tell you. The difference is that the barnacles like this one that have the little shells like this, they're still alive. And the barnacles that look like this is just a hole in the middle. Those ones aren't alive anymore. There used to be a barnacle living there, but there isn't anybody living there anymore. And that little hole, or the beak almost, reminds me of a beak, that closes their barnacle shell, is the thing that keeps them from drying out. They have their two little shells and it holds water in. And other things can use the open holes instead. This is called a copepod. Now, copepods are so teeny tiny that they're almost microscopic, which means it's really hard to see them with just your eyes. But they survive everything. They're sort of like the superheroes of the tide pools. So I have a little game I want us to play. It's called Copepods Survive It All. I'm going to say something that happens in our tide pool. We're all copepods. We're living in a beautiful splash zone tide pool. And after I say that, we're going to say together, copepods survive it all. And that's real. Every time I say something, that really is something that the copepods can survive. So let's start. We're in a beautiful splash zone tide pool. The water is perfect. It's not too sunny, not too cloudy, and copepods survive it all. Now, what about if it gets really warm and the water evaporates from our pool and that salt gets left behind, making our pool really salty? Well, copepods survive it all. How about if it starts raining and all of the salt in our pool starts mixing with the fresh rainwater, so our pool's not very salty at all anymore? Well, copepods survive it all. What about if it gets really hot again and our pool heats up? It's super warm in here. Copepods survive it all. How about it gets so warm that all of the water evaporates and our pool totally dries out? Copepods survive it all. What about our pool has gotten drenched by some really cold ocean water, the tides come back up, and all of a sudden it's super cold in here really fast? Copepods survive it all. So our copepods are sort of like the superheroes of the tide pools. They really can survive almost anything. Now, so to the ocean, into the high tide zone. You can see it on the map here, and you can see all kinds of things in here. Do you think we're going to find more in these pools, more animals, more plants, more life? Or are we going to find less than in the splash zone? I think we might be finding some more. So let's take a look at some of the other animals that we're going to find. The hardest thing about these tide pools is, again, water loss, because they're not super close to the ocean, so they do dry out, and they need to be protected from the sun. The sun beats down really fast and it warms them up, and it can give them a sunburn if it's a squishy bodied animal. So they really need to be able to adapt to protect themselves from losing water and from the sunlight. Here we have 3 of the animals that you may find in the high tide zone. We have some sea anemones behind me. We have a lined shore crab up the top. And we have some more snails down in this corner over in the bottom there. Let's start out with our sea anemones. Now, what would you say if I told you that both this and those on the other end are all sea anemones? This guy looks really weird, doesn't it? Well, this is a sea anemone that is doing something really special. When you go to the beach, or when you go somewhere that's really, really strong, or really, really sunny, and the sun is really strong, it's beating down on you, do you wear anything to protect yourself from the sun? I wear sunscreen. Sometimes I wear a hat. If it's really sunny and I'm sitting for a long time, maybe I use an umbrella. Well, that's sort of what our anemone is doing. It's got all these bits of shells and sand and rocks on the outside of its body. It's grabbed them on purpose out of the water, and it's holding on to them on the outside of its body to use like a shield to protect itself from the sun. So our anemone is sort of using a sunscreen. These are some more snails. These are a different snail than our periwinkle snail up in the splash zone. This one's called a black turban snail, and it's about the size of my thumbnail. It's much bigger than our periwinkle snails. And you can see those shells there look dry. They're not very wet at all. But luckily, our black turban snails are able to do the same thing that the periwinkle snails could. They can shut their front door, their trap door, do you remember the word? Operculum, and keep all of that water in. So while the outside of their shell may dry out, the inside of their shell stays nice and wet for them. This is a lined shore crab. We have a lot of these at the tide pools, and they're one of my favorites because they do something really funny. Now, this crab here didn't just get caught by a wave that had a lot of sea foam in it. It actually blew those bubbles. Crabs are able to get up and walk around, so they don't need to worry too much, but they do have to be out of water sometimes. And when they do, their very sensitive gills are exposed to the air. The outside of their body is made of a hard shell, and so if that hard shell dries out, they'll be fine. But their gills are very sensitive to being dried out. So to adapt and make sure that their gills don't dry out, they blow bubbles. This crab has been sitting here foaming up and blowing bubbles, and those bubbles keep its gills nice and moist so that it doesn't dry out. And they look pretty silly while they're doing it too. Let's move a little bit closer to the ocean, to the mid-tide zone. You can probably see just from this photo, we're starting to see a lot more life in the mid-tide zone. We've got tons of animals that live here. We've only got time to talk about a couple of them, but they're closer to the ocean, so they don't have to worry about water loss as much. But there is something else, another challenge that they have to deal with. Have you ever been to the ocean or the beach and you're standing close to the water and you get knocked over by a wave? That's happened to me. Well, those waves are really strong and they happen all the time, every day. So our animals that live in the mid-tide zone have to deal with really rough waves, and they have to hold on to the rocks to make sure that they don't get flung out of their homes. So all of our animals in the mid-tide zone definitely have adaptations to hold them onto the rocks better. A couple of the animals that we'll see in the mid-tide zone are our sea anemone again here. This particular one is a giant green sea anemone. We have our beautiful blue California mussels up at the top there. And we have some other limpets. These ones are called owl limpets. They're a bit different from our rough limpets, and I'll talk to you about them in a minute. Here's our lovely sea anemone. This one is actually a different kind. This is a sunburst anemone. And I know that because it's got these stripes coming out from the inside of its body away from the mouth towards the tentacles. Anemones, their whole body kind of acts as one big suction cup. They're able to suction down onto the rock, and they have a little bit of glue that holds them down better. And they can sort of squish down to make sure that the waves aren't going to tear them away from their homes. These are more of our barnacles. Now, remember earlier when we talked about the barnacles with open holes or empty shells? Take a look at these guys here. Do you think these barnacles are still alive or not alive anymore? That's right. They've all got holes in the middle, so these ones aren't alive anymore. At one point, there was a barnacle animal in there, but now it's just the shell left over. But even though the animal is gone, the shell is still there. Barnacles use a superglue that they create with their bodies that glues them to the rock forever. In fact, the glue works so well that it's still around long after the barnacle is no longer alive. And actually, dentists use a glue that is very similar to the glue that barnacles use to hold themselves onto the rocks, because that same glue works really well with wet people mouths. So our barnacles have a pretty cool adaptation to hold themselves on. This is a mussel. It doesn't look very much like a mussel from this angle, but it's got all these weird spiky things coming out of it. What do you think that is? What are all those threads or little spikes? Why don't you write it down or tell someone next to you? What do you think that is? Is there anything it reminds you of? What's going on here? Well, those threads coming out of the mussel shell were actually made by the mussel. The mussel makes threads called byssal threads that it secretes and sticks onto the rock. And then it makes another one, secretes a thread, sticks it onto the rock. And it does that hundreds of times until it is so well stuck to the rock that it's not going anywhere. It's kind of like Spider-Man. He makes all the little webs out of his arm, right? Well, that's sort of what our mussel does. It makes these little threads that hold it onto the rock, but it's definitely not going to go swinging through a city. It's going to stay right where it is. This is another kind of limpet. Its shell isn't nearly as rough as our rough limpet, and it's actually quite a bit different than our rough limpet, but the way that it holds on to rocks is the same. It has one big suction cup foot on the bottom, and it suctions down onto the rock and holds on. But what's something that you notice about this photo? There's a couple things that I notice, but what do you notice about this photo? You can tell somebody what you notice, or you can write it down. Well, one thing that I notice is that there isn't really anything else around our owl limpet here. There's a couple of mussels, but there's a lot of area that's just bare rock. Another thing that I notice is that there look like there's all these little lines or scrape marks all along the rock where there's nothing else living. That's kind of weird. Well, I'll tell you what that is. Our owl limpet is a farmer. Our owl limpet is very good at keeping its little patch of algae very clear, and then it eats that algae. Do you know what algae is? Algae is like an underwater plant. Our owl limpet scrapes the algae off the rocks to eat it, and it keeps everything else from living there because it wants to have a nice big patch. They're kind of like little farmers. Let's move even closer to the ocean, to the low tide zone. The low tide zone is hardly ever out of water. It never dries up really because it's always so close to the ocean. And life here is pretty good. But everybody wants to live there because life is pretty good. So it gets really crowded really, really fast. You can see from this photo, there's all kinds of stuff all piled on top of each other, all these animals wanting to have their own space. And When everybody is all crowded together, predators like to come in and try to pick out whoever they can. So our animals in the low tide zone, they have to make sure they've got enough space, but they also have to be really careful and make sure they're not going to get eaten by a predator. A couple of the animals that we'll see in the low tide zone are our lovely sea stars, some purple sea urchins up at the top there, and again, we'll see some more anemones. These ones will usually be bigger, giant green anemones, like in our photo here. Now, our sea stars can actually move around. If they feel like a predator is coming or they want to go somewhere else to eat something else, they can actually move. Do you see along this line here, there are these little tubes that sort of, well, they remind me of macaroni noodles. Those are tube feet. They're tube feet that are very small suction cups that they suction onto the rock, and they can move across the rocks by suctioning on their little tube feet. They also have a really rough skin on the top side. You can probably see a little bit along the bottom here. This bottom side's very rough, but the top is even rougher. So if they sense that a predator is coming, they can move away, or if the predator tries to take a taste, they might not taste very good because they're pretty rough. This is a purple sea urchin. Purple sea urchins are really cool animals. They're this bright, beautiful purple color. And you can see, what do you see all along the outside of this urchin's body? It's got spines. It's got all kinds of spines poking out of its body, which if you tried to pick it up or if a predator tried to grab it, that would probably hurt pretty bad. You might get stuck by one of those spikes. So they're very spiky. You don't want to try to pick them up. But there's also something else I noticed about this urchin. Something to do with the rock. It sort of looks like it's in a hole. In fact, it's a hole that looks perfect for this urchin's size. Well, it is perfect for this urchin's size. This urchin made that hole. It wore away the rock by kind of twisting in, and it made a hole that's perfect for its own body size. So it's got spikes coming out the top, but a predator can't come get it from the sides or from underneath because it's embedded into the rock. So they take really good care to protect themselves from predators. And this is how our anemone protects itself from predators. Have you ever touched an anemone? What did it feel like if you did? If you haven't, what do you think it would feel like? It's probably smooth or squishy, but if you touch its tentacles, it's kind of sticky. It's weird. It's kind of sticky. Well, it's not sticky because it's got an adhesive like a piece of tape does. It's sticky because they have very small stinging cells that are like little harpoons. It's got these stinging cells all along each side of each tentacle, and it shoots out those little harpoons, and those harpoons have a small paralyzing chemical in it that paralyzes its prey and drags it back in towards the mouth, which is this part right here above me. So for humans, luckily, our skin is much too thick to feel those stings or to have any kind of paralyzing effect. But for a very small animal, like a fish or a shrimp or something even smaller, something microscopic, those stinging cells could mean that it's going to be lunch. So our anemone, while they're really pretty, they're a fierce predator of the tide pools. And finally, let's put on our wetsuits, put on our bathing suits, our goggles, our scuba masks, and let's jump into the subtidal zone. What does subtidal mean? Well, subtidal. Sub means under. Tidal means tides or ocean or water. So the subtidal zone is the area that's underwater. In fact, it's underwater all the time. It's never out of water. So you can see like this image behind me, we've got some beautiful kelp forests. You get fish. What are some other subtidal animals that you can think of? Write down your favorite subtidal animal, or you can tell your neighbor. What's an animal that you love that's in the water all the time? You've probably mentioned a lot of great animals. I love sea otters and I love dolphins and I love mola molas, which are sunfish. There's a lot of great subtitling. And the biggest challenge for the subtitle zone is people. They don't have to worry about drying out because they're underwater all the time. They don't have to worry about it getting too warm because that cool water is circulating always. Their biggest challenge is people. Now, sometimes people go fishing, and that's great. I love eating fish. Everybody loves eating fish. Well, maybe not everybody, but it's a great thing to practice eating fish or to go fishing. But sometimes people take too much. And when people take too many fish, too much algae, too many mussels, too many of any of the animals or creatures that live in our oceans, the ecosystem starts hurting. It doesn't have enough of that food source to provide to the rest of the food chain. So in an unprotected area like this, where there's unlimited fishing, you have a lot less life. You have less kelp. You have less fish, less urchins, less of everything. But we have something special here in California called marine protected areas. Let's break that phrase down together. Marine protected areas. What does marine mean? Marine means ocean. What does protected mean? Protected means guarded from harm. We're going to make sure that something is protected, nothing's going to hurt it. And how about area? Well, an area is just a place, any place. So our marine protected areas are underwater places that are guarded from harm. Now, our marine protected areas here in California, they're guarded from harm by the law. In fact, there's 124 of them. The largest network of marine protected areas in the world. So we have a lot of ocean that's protected from harm. And when you have these protected areas where there's either reduced fishing or no fishing at all, life is able to thrive. You get more kelp, more fish, more kinds of fish, more marine mammals, more other algae, more anemones, more of everything. And as those areas get more and more and more, eventually that life spills out into the unprotected areas where fishermen might be able to make their living. Protected area here at Natural Bridges State Beach covers our Tidepool shelf. You can see it here on a map. It's not super big. It's only a couple miles long and it doesn't extend very far into the ocean. But all of our tide pools here at the beach are under this marine protected area. So what does that mean for you? How can you help our marine protected areas? Well, you can help our marine protected areas by following a couple of very specific rules and making sure that you are helping protect them. First of all, there's no collecting when you come to a marine protected area. Collecting can mean going fishing. Collecting can mean taking mussels or animals. Collecting can even mean taking shells or rocks. Everything that you see there is going to be part of the life cycle of something else. If you took some fish, well, that's fish that another animal didn't get to eat. If you take a shell, well, even if the alive animal isn't using the shell anymore, a different animal may use that shell as protection from the sun, or it might break down and use the chemicals that are in that shell. Everything needs everything else. So when you come to a marine protected area, don't take anything home with you. You also don't want to touch any of the animals while we're there, and especially not step on them because you could hurt them or kill them. We don't want to touch any of them because this space is meant for them. This is their home. If you're in your house, in your home, you don't want anybody coming around and bothering you. So our animals are the same way. They're in their special place that is their home. They can't leave. So don't touch them or poke them or bother them because you could hurt them. And even if you're the most gentle possible, it's still more energy that they have to use dealing with us wanting to poke them. So don't poke any of our animals while we're in the tide pools, please. And finally, let's not turn over any rocks. If you turn over a rock, everything that's under that rock is now exposed. And they were probably hiding there for a good reason. Maybe there's a predator around, maybe they're worried about drying out. And if you put that rock back down, well, you could squish them by accident. So if you come to the tide pools, remember those three important rules. No taking, which is collecting. No touching, don't poke anybody. And don't turn over any rocks, because everything is relying on your help to make sure that they have a nice, safe, happy life. Now, before we move on to the nature journaling part of our field trip today, I want you to take a look at this email here. So if you have questions, you are more than welcome to put them in the Q&A, and I'll get to them as soon as we're done with our nature journaling. Or if you're feeling shy or you think of a question later, then you're welcome to email me at this email here, and I will answer your question as soon as I can. Give me 1 second here. All right. Now we're going to do some nature journaling. In a minute here, I'm going to move and you're going to be able to look at this cool tide pool here and just draw. You can write down things that you see. You can list some of the animals. You can draw as many of the animals as you want. And we're going to have just about 10 minutes to sit and draw. And remember to be thinking of questions and putting them in the chat if you have them, because I'll answer them as soon as we're done here. So I'll stop talking now, and I'll let you take a look at this cool tide pool behind me and do a little bit of nature journal. All right. Did you have fun drawing? I really hope you did. We have a question in the Q&A. Emma asks, what do urchins eat? Well, urchins eat kelp. They eat a lot of algae, but especially they love kelp. And kelp is a really super duper important part of their ecosystem. They live in a kelp forest and they eat the kelp. Now, you may have heard that our kelp forests are in trouble. Kelp forests, well, they kind of are in trouble. Sea urchins are taking over everywhere and they're eating all of the kelp. And historically, this wasn't a problem because there is an animal, a really good predator, that's favorite food is sea urchins. Do you know it? You probably already know of this animal. It's otters. Sea otters love eating sea urchins. But some years ago, a lot of our otters were hunted for their pelts. And when those otters were hunted and their population went down, well, the urchins, they didn't have to worry about their biggest predator anymore. So the urchin population exploded. There were tons of them. And all those urchins have to eat. So they munched through tons of kelp, even in some places creating an ecosystem called an urchin barren. An urchin barren just means that the urchins have eaten all of the kelp and there's basically there's no other animals there anymore. So our urchins are super important part of our environment, but it's also important that we still have our apex predators like the sea otters to keep everything else in check, because without our sea otters, if we've got our urchins eating all the kelp for us, well, no otters, no kelp. So it's a good thing that we have a lot of great organizations and protections in place on sea otters to make sure that our kelp forests can recover. Does anybody else have any other questions for me? Ooh, how can we protect tide pools from at home? That's a good question. Well, if you don't live next to the tide pools, just make sure that you're loving them. Learn about the tide pools, visit them sometime, and learn to love the ocean because, you know, the best thing that you can do for them is enjoy them and want to protect them and want to help them. When you're at the tide pools, make sure that you're picking up all of your trash. And like we mentioned before, don't take anything from the tide pools, don't collect, don't poke our animals, and just love them a lot. Any other questions? What's my favorite tide pool creature? Oh, that's a hard one. I love a lot of the animals that are in there. One of my favorites that we didn't get to talk about today is called the Tidepool sculpin. It's kind of fish. It's a very small fish, about this big. And the sculpins are colored so that they blend in with the tide pools. They're kind of stripy and they live in these pools kind of hidden in them. One thing that's super interesting about them, though, is they have individual pools that are their homes. Scientists wanted to know, are these sculpins in any pool randomly and that's where they live? Or do they have a specific one that they always like to go back to? So the scientists took the sculpins and moved them to different pools. And what they found was when they came back the next day after the tide had come up and the sculpins had a chance to move around if they wanted, the sculpins ended up back in the same pool that they started in. So they came back to their home pool and that's where they live. They have their own little homes. And I think that's kind of neat. I think we have time for one more question, if anybody has one. All right, fantastic. Well, just to reiterate, if you think of any more questions and you want to ask, go ahead and send an email to naturalbridges@ports-ca.us and you'll be able to reach me and I would love to answer your questions. But thank you all for all of your lovely questions. Thank you for tuning in today. And I hope you visit a California state park real soon. Bye.